dear students. So now we are going to see basically the application of addition law, and then I think there is something about conditional probability and multiplicative law of probability. And for that we need to read the question first, and then we will discuss A, B, C and D part. So I'm gonna read it. A high school seniors will strong academic record apply to the nation's most selective colleges in greater number each year. Because the number of slots remains relatively stable, some colleges reject more early applicants. The University of Pennsylvania received 2,851 applications for early admission. Of this group, it admitted 1,033 students. So keep in mind that the admitted students and basically early admitted students are 1033 and rejected students are 854 and deferred students are 964. These are the deferred students to the regular admission. And then in the past, Pennsylvania has admitted 18% of the deferred early admission applicants. So this 18% basically probability of admitted students out of deferred students. So this basically a conditional probability. And then the counting the selected, then counting the students admitted early and the student admitted during the regular admission process, the total class size was 2,375. So these are basically admitted students, and which includes basically both early admitted and then laterly admitted students. Now they have explained some of the events which is E, R and D, that represent basically the students who admitted early, and R for rejected outright, and D for deferred to the regular admission pool. So these are basically some of the information that have been provided in this example, and we have to answer first part. In the first part, use the data to estimate the probability of E, probability of R and probability of D, and this part is very easy to understand and go in solution. So we have already seen the total number of applicants are 2,851. So these are total number of applicants here. So these are the total number of applicants, and E basically early admitted students, and we already know from the data these are 1033 students, and R for rejected students, and D basically an event that denotes deferred students. So ultimately our objective is to find the probability of A, probability of E, which is this number out of this number, which is 1033 over 2851. Then probability of rejected student, because the rejected students are 854 divided by total number of students, and then the deferred probability of deferred is associated with the total number of deferred students divided by the total number of applications. So 964 divided by 2851. So this is the answer of part A, and it was, I think, relatively easy. And now we'll move on to the part B, and for part B we need to read it first, and then are events E and D are mutually exclusive, find the probability of E and D. So for this, to answer this question, I think we understand the nature of these events. Basically, E denote for early admission students and D denote for the deferred students. So it is not possible that a student will be admitted early and then will be deferred. So it is not possible. So it means that the events E and D are mutually exclusive. It means that there is no possibility that we will have something here. So we have a null set here. We have a null set. We have a 0 here. Probability of E intersection D is 0, because there is no possibility to have a student who got early admission and then will be deferred. There is no any possibility. Therefore, in the part B, E intersection D will be 0. So you just read this explanation, because it's not possible to have a student who got early admission and deferred at the same time. So this is the answer of part B. Now we move on to the part C, and for part C we have to read first the explanation. For 2375 students admitted to the Pennsylvania. So these are the total number of students, and I think this information have been described here as well. So out of these admitted students, what is the probability that a randomly selected student was accepted during early admission? So what our objective is to calculate the probability of early admission from the admitted students. So now the admitted students are 2375, and out of these admitted students we have to calculate the probability of early admission student, the students who have been accepted during the early admission. So we'll move on part C. So again we have admitted students, and the amount is 2375, and here we need to calculate a conditional probability which says that calculate the probability of early admitted student given that the total number of admitted students. So from the given total, the probability of the early admission is the same one number, that is 1033 over this 2375. Why? Because this is basically a conditional probability, and we already discussed the idea of conditional probability in our class, that the conditional probability basically reduces the sample space. Our total sample space was basically 2851, but because this is a conditional probability, and in the conditional probability we have given these total number of admitted students, these are total number of applicants, and these are total number of admitted students. From these admitted students we have to calculate the probability of early admitted students, and we already know that the admitted students are 1033 students. So this is easy one. And now we'll move on to the part D, and part D a bit tricky one, but I'll try to explain in easy way. Suppose a student applies to Pennsylvania for early admission. What is the probability that the student will be admitted for early admission? So you can clearly understand that the first event we need to identify the early admission, and we already identified, because we say early admission as E, okay, and or is basically will be replaced by union, and then we need another event which is called deferred and later admitted during the regular admission process. So until now we don't have this event, deferred and later admitted during the admission process. So we have to generate this event, because this event has basically two events. One is deferred and later admitted during the regular admission process. So we can write in this way. For this part we need an event that is we just name that event as F, and F is basically a deferred and laterly admitted. So we already denoted deferred as D, and we already know we can replace and with intersection, and laterly admitted students basically A. So this basically a joint probability. Now it has become a joint probability, and we need to find the probability of F, and then accordingly the probability of D intersection A. So we have to see the sequence of this event first. So in these two events, what is happening here? Basically the D is happening first, and then A is happening on later stage, because first of all the student will be deferred and then laterly admitted. So we have to write in that way. So it's a multiplicative law, and in the multiplicative law can be written as probability of D, which is basically unconditional probability, and which is already we already know about the probability of deferred student, that was 964 divided by 2851, and multiply by the probability of A given D. So this is basically probability of admission given the deferred. So we can see this 18% probability from this statement. We already I tried to explain in the statement in the past. Pennsylvania has admitted 18%. The probability of admitted student is 18% of the deferred. So given basically a deferred and probability of admitted students is 18%, we just replace this number here. Probability of admitted given the deferred is 18%. So we just multiply these two numbers and we'll get an answer of 0.06%. So it means that we have successfully obtained the probability of F, that is basically deferred and laterally admitted, is basically 6%. So now our objective is to see again the question first, and then we will see the answer. So what is the probability that the student will be admitted for early admission? That is basically E, or maybe it's a union one. And then deferred and laterally admitted, we have already generated this event, that is called F. The whole this event is basically called F. This one, this is called the F, and this event is called E, and in between we have OR. So it can be written in this way, E or F. So I think now it's easy to understand, now easy to convert in addition law. With the help of addition law, we can convert it to probability of E plus probability of F minus probability of E intersection F. So we already know the probability of E, that is basically 1033 divided by 2851, and we have already calculated in the first part, in the A part, and that is basically 0.3623. And probability of F, we have already calculated this probability of, which is 0.06. And then again probability of E intersection F, that will be again 0, because the same logic, the early admitted student cannot be deferred, because in F we also had the probability of deferred in F. So the same logic is will be applied here, and early admitted students cannot be deferred, so the probability again will be 0 here. So if we sum up these two probabilities, we will have answer of about 22%. So this is the final answer. So this is basically the end of this question. So thanks for listening, and we will see more example in next videos. Have a nice time.